Alright guys, since I was running out of time in my other video, I decided to change to this one for rational zero theorem. So we did start talking about it in the previous video. And remember we talked about how we needed to find the factors of the constant term, and then we would divide that by the factors of the leading coefficient. Okay, and if you remember, the leading coefficient is just the number in front of the front x as long as it's in standard form, meaning the one with the highest exponent is out front. So in this case it would be 1 since I don't see a number in front. So my constant here is 3, right? The one without a variable. And my leading coefficient is 1. So what the rational zero theorem tells us is that we can find some possible zeros. Okay, we're just basically listing all the possibilities of things that could be zeros for this polynomial or solutions when there's no other way to solve it and actually find them outright. And so what we're doing is we're just looking for possibilities that may work or may not, and some of them will, some of them will not. Occasionally none of them will, but generally at least we can find one or two. So the method is just to find all of the factors of the constant. Factors, remember, are numbers that multiply to give you the number. So I know that 1 is a factor of 3, and so is 3. So 1 times 3 is 3. That's why they're factors of 3. There are really no others except for I could use -1 and -3. So a lot of times we just write this as like plus or minus 1 and plus or minus 3 just as a shortcut. Instead of writing all 4 of them out. The factors of 1, well, that's easy. It's just 1, right? There are no other factors of 1. And then the way to find all of these possible zeros is to take these factors of the numerator, or these factors of the constant, and put them in the numerator, and then all the combinations that we can with the factors of the leading coefficient in the denominator. So just taking one of these at a time, I could have +1 over +1. I could have -1 over +1. Or I could have +1 over -1. That's not going to give me a new one because if I actually multiply these out or divide them, -1 divided by 1 is -1. So is 1 divided by -1. So it's not giving me anything new. So I could have 1, I could have -1, or I could have 3 over 1 or -3 over 1. So the possible rational zeros are 1, -1, 3, and -3. Okay, and then it asks us to actually determine if they are zeros. So that's just what we did in the previous video. We can either take these x values and plug them in for x and see if this evaluates to 0. If it does evaluate to 0, we will know that 1 is a factor, or a 0, I guess I should say, of the polynomial because the remainder would be 0, right? The remainder theorem says if I plug this value in for x and it evaluates to 0, then it would be the same as dividing x minus 1 into x to the fourth plus 2x third minus 4x squared minus 2x plus 3, and it going evenly in if that's a 0. If it's not, it would not be. So we can determine if each of these are zeros of the polynomial just by plugging them in, or alternatively, we can use synthetic division in order to determine if they're factors. If I use synthetic division with 1 or -1 or 3 or -3, and I get a remainder of 0, then I'm going to know that they are factors. So let's go ahead and clear this slide so that I can actually now use these. Remember, I had plus or minus 1 and plus or minus 3 as my zeros, or my possible zeros. So I'm going to put plus or minus 1 and plus or minus 3 up here. Now we're actually going to test them to see if they actually are zeros. So just like I explained. So the first one, I'm just going to plug it in because we can do it either way. You can choose. Whoops. So 1 to the fourth plus 2 times 1 to the third minus 4 times 1 squared minus 2 times 1 plus 3. This would give me 1. 1 cubed is 1, and 1 times 2 is 2. -4 times 1 and -2 times 1. So this would give me 3 minus 6 plus 3. which is 6 minus 6, which is 0. So 1 is actually a 0. So actual zeros, we'll put them over here. On your assignment, it just asks you to find at least one that is an actual 0. So once you find one, you're done and you can go on. If you want to find all of them, you can keep going. If I plug -1 in here, -1 to the 4th plus 2 times -1 to the 3rd squared, it gives me -1 to the 4th is +1. -1 cubed is -1 times 2, which is -2. -1 squared is a +1 times -4. -2 times -1 is +2. And we have +3. So if I add up all the positive numbers, 1, 2, 3, 4, 5, 6, 6 minus 6 is 0. So another actual 0 is -1. Okay, let's try one using the synthetic division. So I'm going to put 3 in here. Woo! Grab myself a blue screen. Okay, so I'm going to kind of section this off. So I'm putting the coefficients across the top. I've got a 1, a 2, -4, -2, and 3. I'm looking to see what the remainder is. If it's 0, it is going to be one of the zeros. So you can use either one of these methods that you prefer. It doesn't really matter. Just try one. And if you prefer one or the other, go for it. Doesn't really matter. This is not working, obviously. That's giving me a remainder of 96. So 3 is not an actual 0. We can try the same thing with -3. 1, 2. So basically, it's just two different methods to determine the same thing. Either plug it in or use synthetic division. See if you get that remainder of 0. That is about it. Okay, that one is not going to work out either. That's giving me a really big number here, which does not give me a 0 here. So the actual zeros are 1 and -1. All right, let's just practice one more time on the next slide, just with finding all the possible rational zeros. So we won't actually test each one of these, but we will just practice on which ones are the possible rational zeros. So our constant is -8. So for -8, I could either have 1 times 8 or 2 times 4. And remember, I could have the positive or the negative of each of those values. So those are going to be in the numerator. The leading coefficient is 3. So the possibilities there are plus or minus 1 or plus or minus 3. So now I would go ahead and just write down all the different combinations that I can get from having these numbers on the top and these numbers on the bottom. So because one of our options is a 1, that's just going to basically be that top row, because if I divide any of those by 1, it's not going to change anything. But depending on the combination, sometimes it could be a positive and sometimes it could be a negative of each one of those numbers. So I'm just going to write those ones out. Now we need all of these numbers divided by 3. And again, it could be the positive or negative of all of that. So 1 divided by 3, plus or minus 8 divided by 3, plus or minus 2 divided by 3, and plus or minus 4 divided by 3. So there's a lot more possibilities on this one than on the previous one, simply because our numbers had more factors, our constant and our leading coefficient. So this is all the possibilities. Then you would need to go ahead and start checking to see which ones are actually zeros. And again, on your assignment, you don't have to find all of them that are rational zeros or that are actual zeros. You just need to test until you find at least one. All right? So good luck, guys. Have fun, and I will check back in later. If you have questions, please email me. Bye.